Welcome back. This is an Aleks training video on identifying the intermolecular forces between atoms, ions, and molecules. So remember that we have been working on three types of intermolecular forces. We have the forces that act between every molecule due to a momentary dipole. Remember, a dipole is one side positive, one side negative, just momentary as the electrons are whirring around randomly. So those are called London forces or dispersion forces, and every molecule has and they're very slight. They're not a lot of force, just a little bit, but every molecule with every other molecule exerts a little bit of that tug. The second one we looked at was dipole. Remember, dipole is definite one side positive, one side negative, or part of the molecule is positive, some other part is negative. And all polar molecules, okay, negative and positive sides, or polyatomic ions that are polar, will exert a force on each other, a dipole force. Okay, something I put under dipole, but it's really would be its own, and I think it would be in its own on this question, would be an ion dipole attraction, and that would be something that's polar, a polar molecule attracted to an ion. So if you have an ion, which is not a molecule, it's just something positive or negative, just an atom that's positive or negative, it would be attracted to that other charge, also called an ion dipole. And then the last that we looked at was hydrogen bonding, and hydrogen bonding is anything that tugs between an oxygen hydrogen, a nitrogen hydrogen, or a fluorine hydrogen bond with another one that has a bond like that. Okay, so your question says, what kind of intermolecular forces act between a bromide ion? Okay, so a bromide ion, remember, is just Br negative, so it's an anion, so it's an ion. So I already look at this one that says ion dipole, because since bromine is an ion, I bet you something must be a dipole, maybe, and that would be a possibility. We'd have to check it out. And then the other one would be hydrogen peroxide. Okay, so hydrogen peroxide looks like this. It is oxygen connected to oxygen, then with a hydrogen attached to both of those. So you can see we've got lone pairs here, and so you already can see that it is got hydrogen bonding. And hydrogen bonding always will be polar too, because if you check this out, oxygen is much more electronegative than hydrogen, so you're going to have a negative in that direction and a positive in this direction. And then the same thing happens over here. You're going to have a negative in this direction and a positive in this direction. So you have the H sides are positive and the O sides are negative. Wherever those O's happen to be are going to be negative. So this is polar, and it's also exhibits hydrogen bonding. All right, so let's look at which ones these are going to be. So let's just look at all of them. How about bromine and bromide ions with hydrogen peroxide? Okay, this is going to be dispersion. Okay, all molecules will be some positive on one side, and if you've got a bromine there and a side of a hydrogen peroxide slightly positive, it'll attract. Okay, so number one would be dispersion. And dispersion is almost a given. It's every molecule reacting with every molecule, or every ion reacting with every molecule. How about dipole-dipole? Well, hydrogen peroxide is polar, but bromine is not polar. It's just an ion. It's got a negative side, but it doesn't have a positive side. So I can't have dipole-dipole attractions. Can I have ion dipole attractions? Yeah, because bromine's an ion and hydrogen peroxide is a dipole. Okay, so number two would be ion dipole. I think you're going to need the dash there, because ion dipole would be considered one thing, so you'd need a dash. And then hydrogen bonding, peroxide has hydrogen bonding, but bromine doesn't have oxygen or nitrogen or fluorine, and there's no hydrogen there. Okay, so there can't be hydrogen bonding. So the only two that you're going to see in this example would be dispersion forces and ion dipole forces. Okay, so good example, I think.